Hafiz here?
As Hafiz.
Yeah, so is there any material that meets the requirement for
the material is already exists. The name is HGCRSE form.
so it's already exists in the real life?
Yeah, it's mercury,
So-
mercury, chromium, and what HGCR. And
So
mercury, thorium, selenite. Yes.
Okay, so that's the main points that we need to confirm after you've done your calculation. Okay, mercury, chromium, selenium, tetraselenium. Okay, yeah, whatever. I'm crazy about the chemistry names. Yeah. So basically, it's already exists,
Yes,
right?
Yeah.
So after your calculation, you already got the shift currents or shift conductivity or whatever you mentioned before. You can confirm, right? You can confirm
Right.
how close or how far your calculations end up with if you want to compare between your calculation and the real materials, and you already know the properties of that real materials, right? How much is the how much is the conductivity shift, right? Okay, good. That's the main point. The second one, do you think that it's already measurable that you will be able to do the calculation in the meantime? Means in the next 2 or 3 weeks you're gonna have the final results. So you are not going to be so far. You already spent a lot of time, right? So in the next 2 or 3 weeks you're gonna have the result, and then you will be presenting on the final results, right?
Right. I will do.
Okay,
Mr.
so
Hafiz.
this is part of our scheme, right? All of the students with a very high achievement need to be very quick to do the research. And the last requirement that I want, once I have the head of department, because Rofii is going to be graduated in the meantime, while I'm still at the head of the school. So I asked you, Rofii, would you like to be able to be reviewed by external reviewer? Because this is Husky is actually your second, your Pak Angga is the first or the main principal supervisor. Pak Husky is the co-supervisor, and I'm the internal examiner. Now we are going to find the external examiner. Are you happy with this idea? If not, we cancel all of this exam.
So do
Then
you
you need
want
to then you need to be agree.
Yeah,
You
yeah.
need to say yes.
So if I may rearrange Pak Heri's question. So do you want to be examined by some people outside our department
Oh.
to be your second examination for? So I guess it is Dr. Paula Blanco.
No. Dr. Paula Blanco is not in this matter. So I think Pak Eski need to find someone in Luxembourg, or whoever working on this. Maybe just partner or co-partners in Luxembourg. We'll be very happy to examine Rofii.
So to put it simple, Rofii, do you accept the challenge to be examined by other researcher outside UNER, and of
Yeah.
course,
Of course, Mr. I think it is no
Okay.
problem.
international researcher, yeah.
Okay, that's the good things.
Yeah.
So we are going to invite the external to examine Rofii in the next 2 or 3 weeks.
Yeah.
And we are
Or-
going to do so.
Or you can spill to Pak Heri that you already done your calculation. So how far is he going for the result for the thesis step, and then for the publication step, and so on.
This is we already had the scheme, right? For the students who got the very high achievement, we need to have the scenario that the first exam for the proposal and the final exam need to be close, not take some time.
Yes,
okay?
yes.
To be more
Expect, yeah.
efficient. And the second one, if Rofii can do graduation before January, means Rofii can graduate in 3.5 years. Then the more beneficial for Rofii is because in March or April, see, he needs to apply for the scholarship, which is LPDP is the closest one. So then by doing the final exam with the external examiner, I hope Rofii can do like some recommendation or reference from the external examiners for your academic careers. You need to pursue your academic pursuit, right? You want to go overseas, right?
Right.
That's why we ask this question. I won't ask this question to someone else if they are not going to be able to do so. All right. So the main points, while all of the calculation is already measurable, it's already going to ready for the next 2 or 3 weeks for the final exams, then let's we do it, and then please provide the external examiner for your potential career or pathways, academic pathways. Do you have any idea, Rofii, who is there?
Who is the
Maybe Pak Eski have some recommendation.
means you have
Okay.
no idea if you ask my Eski then.
Yeah, don't worry, I can provide you 1%.
Okay, just provide the ones from Luxembourg. What is the university actually, Pak Eski?
It's only one university in Luxembourg, University of Luxembourg.
The
But
University of Luxembourg. Okay.
probably this will not be from Luxembourg. I think from the more suitable maybe from Thailand, I think.
Okay. Can you find someone from EU Leuven if there is someone who work with these matters?
Leuven in Belgium?
Yeah.
Yeah, but
Yeah.
I don't find someone that really
Yeah.
fits. Yeah. So one candidate will be one from Thailand or the other from Korea. But for
Okay.
this presentation, I think for the one that I invite from Korea, it's really the expert, but Rofii needs to provide more calculation. But I think it's not possible if you do it only in 3 weeks.
Okay.
So,
Okay.
but
Is
yeah, in the end,
it
probably we
Mr.
can.
Hong Kim Min, Mr. Eski?
Yeah, yeah, that's the one.
So you already know the examiner, right? So then we are going to invite in Sophia, and then he will need to accept or whatever. You need to let him know how to do so. Okay?
Okay.
In the
Yeah,
Sophia.
in
Basically,
next
you
week
have
I will.
writing, right? So Rofii, so basically you have done your thesis writing, right? So you have all the you have all the data, you have all the result, and you have written everything
In English, right? In English version,
yeah,
right?
in English or still in Bahasa?
For the result enggak, because it is like there
still
are
in Bahasa.
some revision in my work that I just
Okay.
report to Pak Eski and Angga. So it is
Yeah.
I not already write in English in
Okay.
this.
So your write up is still in Bahasa. So okay. So I think you can use this 2 or 3 weeks to translate and to revise anything. So in the 4th week, so we can conduct the research progress presentation as suggested by Pak Heri. And then you graduate, and then you go lah to wherever you want, Japan, Korea, or yeah.
So more likely, if you got the external examiner from Korea, you will ask him or her to get some references. So you got like the letter
But
of
Pak Heri,
reference.
I think we can discuss it internally. So
Yes,
I
sure.
will discuss first with Pak Eski, and then we will contact you for the name. And
Yeah.
hopefully, he or she, have time for that. So in the in the day, in the week, in the month, we will conduct the evaluation, the test, the examination.
Okay.
Okay. So,
So
anything?
I think that's enough for today, right?
Okay. So Pak Heri is enough. So Pak Eski, do you
Okay.
have one or two things?
I have several questions. Do you calculate the whole terms in the electrical nonlinear response, the second order nonlinear response?
For the what is it, Pak Eski?
Okay, so I think you didn't explain what is shift current, shift conductivity. What is this?
From what I know, it is like the what is that? If we get two bands like conduction band and valence band, the electron from the what is that? From the valence band can go to what is that? Can move, and not only in momentum space but also in space. So we call them shift conductivity.
Okay, so this is the real space motion of electron because of interband transition. And what are other terms in the second order response that you actually don't calculate?
The another term of shift current, or what is that current?
So you mentioned about proportionality of J equal sigma times E square. Yeah, okay. There are other terms actually, not only shift current. What are they in the E square?
The conductivity.
No,
You calculate the conductivity.
you calculate the conductivity, but only for particular case that you consider shift current. But what are the other terms? Do you understand?
The other term of shift current, Mr. Reski, or what?
No, the other terms of nonlinear effects.
Second harmonic generation.
Okay. What is the difference between second harmonic generation and your shift current?
In second harmonic generation, if we get the light as an input, maybe the light with the frequency of omega, so we can get the output that doubling the input in doubling the frequency
Okay,
of the
the
input,
output has 2 omega frequency.
omega, and in
What about shift current?
shift current, we get the omega, but the output is 0. Like if we combine the omega and minus
The
omega,
output is DC.
Yeah.
Okay, so that's the most important thing that you need to mention, because people don't understand what is the relationship between shift current and
Shift current.
photovoltaic effect.
Right.
Then people will think that, okay, you will calculate all the response in the nonlinear effect. No, that should be mentioned in your limitation of study. You didn't mention it, or probably you didn't aware that this is that I'm doing.
I think he mentioned that he just calculate the second order, right? Not the third.
Yeah, but in the second order has many terms.
Oh, okay, yeah.
There are
In the
second
second
harmonic
order,
generation.
Rofii are not going to do all of those things.
Actually,
Yeah.
I mentioned in here, Mr. Reski. Wait,
No, but when did you mention that the output is DC?
well, not here.
No,
I
no,
didn't mention yet.
he didn't mention about that.
That's the
in here.
most important thing. Yeah, I understand you mentioned about second order. I understand, but in the second order there are many other terms.
Yeah.
You don't calculate second harmonic generation, no. But why? So what is the relationship BVPE with the nonlinear effect?
Yeah, because in this BPVE effect, we expect that we get the DC current from the light.
Yes, that's need to be mentioned. That's the BPVE. So in J2 like this, there are many different omega. There are many different spectrum of frequency, but you only isolate the frequency that is DC, the zero frequency, and it's only come from the shift current. Okay. Can you go slide number 10? Probably no. Go one more slide before. Yeah, this one. This plot. I like to see the plot. In the plot in the right side. Do you plot this for particular Dirac spectrum or for the general Dirac spectrum?
For the general.
No, it's for particular. What is the particular case for this?
Actually, I don't get what the point of our of your question, Mr. Reski.
So probably you don't understand what you are plotting. What are you plotting here? Energy as function of
Versus of momentum.
momentum. What is the mass in the plot?
Oh yeah. In this spot, I said the in this relative energy, I said the mass of this plot to be 0. Yes, it
Yes,
is
so
not
you
general.
need to understand what you are
Yeah.
plotting, because here, if what happened if the mass is not 0?
If it is the the mass in this in here and not equal to 0, so it is like there are a band gap, and
Okay.
it's like wait, if I draw, wait, let's see.
Yeah, okay, I get your point.
Yeah,
It's
it
okay.
means the
Okay.
dispersion is changing, right? There's the gaps on the dispersions.
Yeah. Okay. Okay, good. I think it's okay for me. Oh, okay.
Good.
One more. Okay, one more thing. You mentioned about graphene. Graphene can be the quasi-particle with 0 mass, and you mentioned about many electrons problems. Is it really that many electrons can give you linear dispersion like in graphene? Is it really the concept of band structure in solid-state physics? Do you understand? What do you mention this? What is the origin of linear dispersion in graphene?
Theory.
This is a test of this is the test of solid-state physics. What did you say when you present this?
I just say that if that the single particle of electron and the quasi particle of electron had different behavior. Like
Okay, but in the band structure, is it the behavior of single electron or multi-electrons?
multi electron
No, it's single.
in the band structure.
Yeah, the band structure is the properties of single electron. So what makes the dispersion like this? What is the difference with the electron in vacuum?
There is
Yes,
the potential
exactly.
in the
So when
material.
electron is trapped inside the potential, like here we choose a hexagonal like this, then you get this dispersion. So that's the interaction between electron and the potential. That's why it's different from the electron vacuum. But it's not multi-particle effect. That's why you can calculate the band structure. Then if you have multi-particle effect, then you need ask Dr. Angga for this. It's a Green's function, and then you need to solve this self-energy. You don't get the band structure. You only get the density of state. Okay. Good.
Okay, thanks, Mr. Asif.
Okay.
Okay, Pak Eski, thank you very much. So one question from me, Rofii, is, so do you have any experimental result that leads your calculation, or your calculation comes to suggest experimental pathway? So hey, experimentalist, I have this kind of result, this kind of calculation. So according to this, blah 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 blah, and you should do the experimental based on my calculation, or your calculation try to explain some data.
I think the second choice, Angga, because
Okay.
I don't get any experimental result.
Okay, so it's very good. Yeah. So the novelty is there. So and also I believe that since you are working with Pak Eski, there is no doubt about that. Okay, so I think that's all, Pak Heri, Pak Eski. So we already about 1 hour for Rofii's presentation. And thank you very much all for Pak Eski, for Pak Heri, for Rofii, and all of the audience. Congratulations, Rofii, to pass this step. So for the grading, so we can directly fill in the system. Yeah, so Rofii, please inform Pak Eski about our Sophia system so he can grade your presentation ya. And ya, saya rasa segitu saja berarti. Selesai berarti ya. Terima kasih
Terima
banyak.
kasih. Selamat Rofii.
Terima kasih Pak Eski.
Terima
Salam
kasih Pak
kenal
Heri
ya.
ya. Mari ya.
Makasih
Ya,
Bangga,
ya.
Pak Eski, Pak Heri,
Nanti
dan
Kita
teman-teman
ketemu
semua.
satu-satu ujiannya Rofii.
Ya, mungkin nanti diskusinya berikutnya dengan Pak Eski bisa lebih saintifik Pak Heri ya, terkait
Ya.
tadi ada masalah-masalah energi yang ternyata bisa kita kerjakan dari sudut pandang.
Kita undang aja lah Pak Eski di hari Selasa gitu loh. Untuk
Oh,
diskusi Selasa kita.
waktu itu pernah kita undang, tapi saya undangnya itu di kelas fisika kuantum. Jadi
kita undang yang untuk departemen gitu loh.
Oke.
oke lah, nanti bisa diagendakan.
Ya,
Oke, makasih banyak Pak Eski, Pak Heri, dan
sama-sama.
teman semua ya. Rofii, selamat. Pokoknya dalam waktu 2-3 minggu kamu selesaikan yang perlu kamu selesaikan, datanya semuanya dikomplitkan, plotnya tolong kamu benerin, terus bahasa Inggris, and then nanti saya dan Pak Eski akan berdiskusi mengenai calon penguji keduamu yang berasal dari luar Indonesia.
Oke.
Atau bisa Indonesia dengan international exposure nggak?
Bisa mungkin ya. Atau
Misalkan dari UI atau ITB, kalau misalkan kita nggak dapat yang dari luar, karena ini juga ada constraint waktu ya.
Ya. Ya kita
Takutnya-
coba dulu yang luar kalau bisa, kalau nggak bisa nanti bisa yang Indonesia exposure luar gitu kan.
Ya, bisa gitu. Oke, kalau begitu terima kasih. Ini saya tutup Zoom-nya ya.
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 Karena kita harus melangkah ke agenda berikutnya. Makasih Pak Heri, Pak Eski.
Terima kasih.
Pero,
Ya.
stop ya. Sip.
Terima kasih Bangga, Pak Heri, Pak
Ya,
Eski,
Yo.
dan teman-teman semuanya yang sudah hadir di sini.
Ya,
Mari.
selamat. Saya tutup.
Ya.